Okay, we're back with chapter 6. In previous time, we saw that there is a potential relationship worthy of exploration between two sets of data, that they may have something linking them together, and we seek to, explain and understand that relationship. And so it begins by, observing the data and then trying to see perhaps what might cause them to be linked. Here we go. The example that we saw recently dealt with young people throwing a discus, and we were measuring two things about these people. First was how old they are, and second was how far they could throw the discus. The presumption, I think, is that older students, young people, would be able to throw it farther. Of course, at some point, that's no longer going to be true. I can see here already that the athlete identified as athlete I is 20 years old and could throw the discus 50 meters, which is a good old long way. Now, I'm considerably older than 20, but I don't think I could throw it 50 meters, meaning this upward trend of the data, it doesn't go on forever, and I don't think that if you had somebody that your family knew who was 100 years old, that they're going to throw it even further still. I think that's exceedingly unlikely. So what are we going to do? Well, as always, we're going to, examine the limits of what interpolation and extrapolation can do for us. But also now, once we have the data there, we're just trying to explore relationships within the data set. So I've taken a little screen capture of that, and there it is there. And you can see that there definitely appears to be a trend. Notice that in all that data field, or that dot field, that is the age increases as you move further along this direction on the horizontal axis. The data points are moving up. So we would say that, the distance that they can throw is also increasing. What we're seeking to do in this chapter is first off to identify, is there a trend that's worthy of exploration? And if there is, to what extent is it mostly going upward? Or potentially, is it going downward? In some cases, that will be true. And then once we have that, is to identify just how streamlined that trend is. Is it very uniformly almost like a perfect straight line? Or is it a loose collection of dots that seem to be traveling in the same direction? So we're going to be discussing not only the direction of this presumed correlation or this relationship, but also the strength of it too. So here we go, and you can hit pause and read that if you like. All right, here we go. So the first part about correlation refers to the direction. You can see in this first case here we have an upward. Now, the amount of upwardness is not important. You could have data that's pointing sharply up or just loosely up. It doesn't make any difference. We just say it's positive. Whereas this one here is called negative correlation because the data points are traveling downward as you move across from left to right. If it's hard to spot a trend at all, we say that there's no correlation, and then we're going to get into ways of measuring it. How do we measure it? Well, it's called, here's its formal name, the Pearson's product moment correlation coefficient. Most people would simply just call it the correlation coefficient, and some people even further simply refer to it as the letter R. And here it is, the Pearson product moment correlation coefficient R. Now, if you are given a set of data where there's potential linkage between them, like there is in all of these cases here with X's and Y's, there is a formula, and you can see it there at the bottom, to figure it out. Now, the majority of students will never, ever have to do this on their own, all those different pieces, all that big calculation, because computers and calculators can do it for us now, especially the GDC that we use is really, really good at it, and it's very efficient. The reason I present this is that some students, remember I said most students, some students may elect to do a course, an internal assessment for this course that, goes along the lines of statistics with two variables. And if that's true, you may have to do this in your project to show that you understand it, not simply just using the calculator to provide you with the numerical evidence that you need. Okay, so here we go, the product moment correlation coefficient. What are we looking at here? First things first, the values of R can range from -1 at its absolute lowest to +1 at its absolute highest. And what's happening at those endpoints, -1 and 1, and what's happening in between. That's what happens next. First things first, if the R value, which we will compute soon, is a negative number, that's an indicator of negative correlation. If the R value is a positive number, that indicates positive correlation. Now, what about all the numbers in between? The closer the R value is to its endpoints, meaning -1 or +1, the stronger the correlation, meaning the tightness of fit or the trend is more and more discernible. If you had R equaling 1 precisely, that means every data point would be in a perfectly straight line with no dot stepping out at all. If you have a high number like 0.9, still under 1, but 0.9, it means it's really strong. It's very, very close, but they're not perfectly in a straight line. And you probably get the idea from there. In the middle, halfway between -1 and +1 is 0, and 0 indicates that there is no correlation between the two variables, and so the statistics theory that we would be pursuing isn't worthy of pursuing because the data is not linked. And there you go. So the further you get along toward either +1 or -1 indicates the strength of correlation, and whether it's positive or negative indicates whether it's positively or negatively correlated. Now, here's some diagrams I got from another textbook. You can see that the tighter the packing of the points around that trend line or so-called line of best fit is the indicator of how strong it is. You can see that the dots are getting looser and looser around that line, still seemingly having a positive relationship, meaning it's pointing upward as X grows as opposed to pointing downward. Now, in this case here, those dots are tightly packed, so we would say it's strong correlation, but it's negative because it's pointing downward as opposed to upward. And again, it's getting looser and looser, and so our R values would be getting closer and closer towards 0 in those cases. Now, this is from when you actually have the R value, and you have to bear with me for a bit. We're going to compute it soon. Depending on the size of the R value, they're giving you little diagrams to represent how tightly packed. You can see in this first one here, if R is 1, it is perfectly straight line. And if R is -1, it's also a perfect straight line. It's just in the negative direction. And as we move closer towards 0, either from the negative side or the positive side, you can see that those data points get less and less tightly bound together around a straight line. Now, this graphic does come from our textbook, and this is kind of the standard. I mean, the last one was being hyper precise. You can see that it goes up by quarters. The absolute value there just means that whether it's positive or negative doesn't matter. We're talking about how far away from 0, and these are the common expressions that we refer to it. It's a little vague still, but it's deliberately vague. And let's take a look. Some of the exercises that we're going to be doing, I'm going to do 2 of them for you today, and it's in exercise 6C. And we're going to be taking a look at potential correlation in 2 reality-based scenarios here. A school grading system gives grades out from 0 to 10, and it also canvassed their students to find out how hard they've been working, how many hours they've been studying. So what we're going to do is we're first going to give them a score for their hours that they've worked, probably self-identified. And then we're going to figure out what grades they're getting. I guess the idea here is you study harder, you get rewarded with higher grades. So what are we going to do? We're going to find the Pearson product moment correlation coefficient. We're going to find R, essentially. Then we're going to describe, based on the previous slides, what that R value means. And then in terms of the real reality-based scenario that we have here, we're going to translate it back into words about grades and schools and students and studying, and to really show that we understand what that means. Now, I've made a little video here. I'm going to start it yet because we've dealt with spreadsheets quite a bit already, and I don't think it's necessary for me to show you how I can type in that data. I just pre-installed it to save a bit of time. One thing I would, however, do is whenever you're done, go down to the bottom and check that it finished correctly. And the 10th data point is the 10th one in the chart. We've given the titles S and G. You may recall that we can't do very much unless we have given those sets names. Here we go. We're going to make a new calculator page. Menu, submenu, statistics. And right below where we used to go, stat calculations, it said 1 variable stats. Now we're going to 2 variable stats. And we're going to investigate the links between them. Not just information about each of the variables, but then also the relationship between them. And I hit OK, and you can see here that this is a really long list of stuff. Go back to the top here. The S information, which is the number of hours studied. You can see there's the mean, regular stuff, all the things, standard deviation that we did before. And we get into the Y values, same as before. Now, this is the information related to the grades. And then out here it is finally, 2/3 the way down that screen here, you can see right there, put it in the middle, R. It just tells you the value R. You need to know how to get to that stage to find it, and now you need to know what to do with it. What does it mean? What does it tell us? 0.88, there's tons of other stuff here. We'll get to all that. You can see the IQR stuff. There's lots going on. So we go back to our chart, and I saw that that R value was 0.88, and it was positive 0.88, which indicates that we're in this zone down here. So we have a strong correlation between increasing the number of hours that you study compared to what your grade on that 0 to 10 scale would be. Describe the correlation. I'm going to say it's strong and positive. Comment on the effect. Increase your study hours, you're going to very likely increase your grades. Another question from 6C, number 5. Here we've got weights that are going to be attached to a spring and suspended by something horizontal. I went and I found a picture online of what that looks like, something like this. Now, I'm going to deliberately, just like last time, I'm not going to graph this. I'm not going to show you a scatter plot of this. You, of course, can do it on your own if you like. But I'm going to see if I can tell what this graph, the scatter plot of this data would look like if I were to graph it just from knowing the value of R. And the simple answer is you should be able to. So I went ahead and I made another spreadsheet here. And again, a pre-installed data. Just check to make sure that the 10th and final one's coincidentally also the 10th one here. It finishes at 250 and 16. Perfect. So I can make a new calculator menu. Calculator screen. Go into menu, stats submenu, and we're doing a stat calculation, and we're doing 2 variable stats to investigate how these 2 groups of data are linked. Weight was the independent variable, length was the dependent variable, and here's your familiar list now. And you go all the way up and you're looking for R, and there it is. And wow, that is very, very close to 1. So what would it mean in terms of attaching weight to vertical springs? Well, it would mean if the value is essentially 0.99, it's exceedingly close to 1, which is very strong. And again, it's positive correlation, which means that if I was to graph this, those data points would be ever so nearly and perfectly in a straight line. And that's it. So we can tell that from just that R value. And it would be pointing upward. All right, so a couple questions here. Same old stuff. This is getting you some facility and practice with the TI calculator. Different reality-based scenarios here. Maybe some positive and some negative correlations. That was 6B. Now we can do some 6D as well. A couple more some more questions. And I've already done C, so you can see that you don't have to do those ones at all. You just have to do those ones there. 6B and 6D. Okay, good luck.